For generations, we've been taught to think about stress in materials, and it's mostly wrong.
In engineering, we often start with this. It feels simple and pretty intuitive.
But here's the thing. While that idea is useful, it can be really misleading.
We're trained to see the world through the lens of force, but that's only half the picture. And it's a natural way to think. Force is obvious. Deformation? That's way more subtle.
And that change is real. You just need special instruments to actually measure it.
To really get it, we have to look past the force to what's actually happening inside.
So what does the material itself actually feel?
It feels deformation, a real physical change in its shape, right down at the atomic level.
And this right here is the key. Deformation happens to the material. Stress is how it reacts.
Let's make this crystal clear with a simple thought experiment. It really helps.
Okay, picture a simple metal bar. It's at room temp, nothing is touching it.
At this starting temperature, everything inside is totally neutral, no stress at all.
Now what if we lock it in place? Its ends are fixed. They absolutely cannot move.
Okay, now we heat it up. That metal wants to expand, to get longer.
That internal push against the walls, that's the stress. It's the material fighting back. Now think about that. We didn't add any outside force, but it's under huge stress.
The stress is there for one reason. It wasn't allowed to deform. That's the whole idea.
So why is this shift in thinking so important? Why does it really matter?
Well, because thinking deformation first unlocks pretty much all complex material behavior. Take fatigue. It's not about one big force. It's about tiny, repeated deformations over time. Even our most powerful simulation software, FEA, works this way. It solves for deformation first.
And this leads us to the next big question you should ask about any material you use.
We'll dig into that line between elastic and plastic behavior in our next explainer.